We have discussed dot product of vectors in the previous class. Today we will be continuing with the same, but we will be talking about the second method of doing the product, that is your cross product of vectors. Cross product of vectors is simply denoted by sign of cross, as I have already discussed with you. And whenever I am talking about the cross product of two vectors, the quantity as a result which I get, that is a vector quantity, and that is why we call this cross product as the vector product. So if I say vector product or I say cross product, meaning is same. I am getting the result because of the cross product of two vectors as a vector quantity. So if it is a vector quantity, then it has to have some direction also, and direction is always perpendicular to the plane consisting of given two vectors. Like if I am having these examples with me, if I am talking about the torque, we will be doing it in detail of course. Then it is cross product of R and F. So if I am taking R vector here, I turn my finger in the direction of F. Then the direction in which my thumb points gives me the direction of the torque. That means it is always perpendicular to the plane consisting of the given two vectors. Similarly, we will be just talking about instantaneous velocity in terms of angular velocity and the radius vector. So if I this is also perpendicular to the plane consisting of angular velocity and radius vector. Instantaneous velocity, of course we have, you all know the definition for instantaneous velocity, at a particular instant of time, when of course when we are talking in the circular motion, then only we will be deriving this relation with you. So two examples should be known to you whenever asked. So if I have to write it in, means I want to define the cross product of two vectors, then I will write it as A vector cross B vector, that is equals to the magnitude of A vector into magnitude of B vector and sine of the angle between the two given vectors. So theta is the angle between the A vector and the B vector. So and n cap here is a unit vector which is perpendicular to both A and B. So n vector is always perpendicular to the plane consisting of A and B vectors. As you have done earlier also, we can find it by using Maxwell corkscrew rule, means by moving the screw in the upward or in the downward direction, clockwise or anti-clockwise. Then I can get the direction of the third vector which is perpendicular to the both, or I can use the right hand screw rule. So both the rules are there to find the direction of n cap. Of course, n cap is a unit vector which is perpendicular to the plane consisting of A and B vector. So now it means we are in the three dimensions. So we should be having the three-dimensional view in our mind to understand it. So when you have to find the direction, when you are drawing the vectors in your notebook, just you take care that if it is your notebook, you put your hand in along the first vector and turn it towards the second vector. And if the thumb is pointing, whichever direction is the direction of the resultant vector, which is the cross product of A and B. If it is pointing in the outward direction, it means upward direction, then it is taken as positive. If I am moving otherwise, I am keeping my hand on the second vector first, B cross A if I want to take, then I will be putting my fingers on the B vector. I will turn it towards A vector. Then you can see your thumb is pointing inward into the notebook. So that is inward direction, or away from you, that is taken as negative. So outward direction is taken as positive, inward direction is taken as negative by convention only. So it means whenever we have to write, I can write this also, that this is like in this diagram we are showing you when we are keeping the fingers on the A vector, we are turning it towards B vector, I am getting in the outward direction, upward direction, that is positive direction. Now you can do it By putting your fingers on the B vector and turn it towards A vector, you will see your thumb points inward. It means into the notebook. So then it will be negative direction, or simply you can write inward direction. So this is the right hand thumb rule, right hand screw rule we can call, which is helping me to find the direction of the result of the cross product of the given two vectors. So direction is very important, and most of the times in the numericals you have to tell the direction, and this is to be used further in the coming lectures also. Now to study the geometrical interpretation of the vector product, it means where I can use it, what is the physical significance, you may say, of the vector product of the two vectors. Now if I am taking OP is the A vector, OQ is the B vector, and theta is the angle between A and B vector. Now if you complete the parallelogram, you can complete the parallelogram OQTP. You draw the projection from Q on OP, then of course this ON will be equals to B cos theta, as we have already discussed in dot product, and this perpendicular line will be equals to B sin theta. That you can also verify from your previous knowledge, like if in the right angle triangle you want to find the value of sin theta is perpendicular upon hypotenuse. Perpendicular means QN divided by B. So sin theta is Qn divided by B. So Qn will be equals to B sin theta. So this diagram you can complete. Now if you see the diagram and your knowledge on the definition of the cross product of the vector, definition says cross product of two vectors. If I want to talk about only the magnitude, this modular sign is simply to show the magnitude of A vector and B vector. It means I am talking about the magnitude of A cross B. Then it is equal to the product of the magnitudes of A vector, magnitude of B vector, and sine of the theta between the two. Sine of the angle between the two, I can say. Now A vector magnitude is given in this diagram by this length OP is the magnitude of A vector. If I take the length OQ, it gives me the magnitude of B vector. And this is angle theta, which is shown to you in the diagram. So I can write sin theta. Now from this diagram, this OQ sin theta, that is equals to Qn, because sin theta is Qn upon OQ. So from that formula you can write this OQ sin theta, it is equals to Qn. So I am getting magnitude of A cross B, it is equals to OP into Qn. Now OP is A vector of course, and Qn is B sin theta. So this is equals to AB sin theta. And this is actually what? This is your OP into Qn gives you the area of the parallelogram OQTP. So it means this knowledge of finding the cross product of these two vectors which are forming the adjacent sides of the parallelogram, that gives me the area of that parallelogram. This is one thing which you have to keep it in your mind. Second thing, if I join QP, I'm joining this Q and P points, then what I'm finding, that I'm simply dividing this parallelogram into two equal triangles. One triangle is OQP and the second triangle is QTP. So you can see that this area of the parallelogram, I can write it as, if I multiply by 2 and divide by 2, it will not make any change on my equation. So in this equation, A cross B, can be written as twice of half of OP into QN. So it means this half of OP into QN is what? That is giving me the area of this triangle POQ. Any one triangle you can take. So this means A cross B, it is coming out to be twice of the area of the triangle POQ. So it means from this knowledge, simply dividing this magnitude of the cross product of these two vectors which are forming the parallelogram, of course these are the adjacent sides of a parallelogram, these two vectors, then I can find the area of that triangle is there also by having the knowledge of cross product of vectors. cross product, or I say simply vector product, meaning is same. So this is very important because you may be asked a direct question, as well as this concept can be used in solving the various numericals also. Now we want to talk about the properties of the vector product. Vector product, it is found to be anticommutative. First property is it is anticommutative, or you can say that it is not following the commutative law. Though if you see A cross B by the help of this diagram, if you are taking A vector this way, you are turning towards B vector. It is coming upward. If you just put it in your notebook, outward or from your notebook. When you are turning it anti-clockwise, it means, just to remember that also, you can see anti-clockwise means upward, and when you turn clockwise, it is away from me into the paper, it is downward and with negative sign. So both the times, if you see, magnitudes will come out same. A cross B, it is equals to AB sin theta. But the direction and cap will be different for both the cases. Like if I am going from A to B, it is coming outward direction. If I am going from B to A, it is coming inward direction. So directions are opposite. So I can say otherwise A cross B, it is equals to negative of B cross A. Because magnitudes are same, only the direction is opposite. But otherwise, to say that A cross B, if I am talking about the vectors, it is not equals to B cross A. So this you have to note, that it is not following the commutative law. So vector product is anti-commutative. Next thing with you is, as we have done dot product, similarly if you wish, you can prove this thing, that it is associative over the multiplication. That means vector product of two vectors obeys the distributive law of multiplication. It means A vector plus B vector, if I am doing cross product with C vector, it is giving me the same result as A cross C, because I am keeping the order same, plus B cross C. But if I change the order, then of course it will not be following this equation. So you have to keep the order same, then this equation will be followed. Again, this is very important. If you are taking the cross product of vector with itself, it means A cross A vector cross A vector. If you are taking, then it is, of course, theta is 0. It means sin theta will be 0. So sin 0 is 0, I can say. So this A cross A, the cross product of vector with itself, is giving me 0 vector. So we have already discussed about the 0 vector in detail. So you should be knowing, if I am taking cross product of a vector with itself, then it is giving me 0. So of course you all are supposed to put the vector sign whenever you are talking about the vector quantities. This should be known to you. I have already told you number of times. Yeah. Ahead. Now if I am saying that A cross B is 0, only if theta is 0, that is same repetition, but now I am not multiplying with the same vector, but I am talking about two different vectors with me. Then it means I am having here's A vector cross B vector. The product will be 0, of course, if theta is 0. And if I talk in terms of the unit vector, you all know we have to put the cap over it. So if I am talking about the vectors, vector sign should be there. And when I am talking about the unit vectors, cap should be there over it. It means two non-zero vectors can also give you the 0 result if theta is 0. So it means if I am talking about the unit vectors, like I am multiplying unit vector I cap with itself, I cap with I cap, then it means the theta is 0, so this result will be 0. Similarly, j cap cross j cap is also 0. K cap cross k cap is also 0. So this thing is to be noted. While when we discussed dot product, then I dot I was 1. So just to compare the things, you should be able to make a table and keep the things in your mind. so that while solving numericals you should not face any problem. Now if theta is 90 degree, then sine 90 is 1. Now if you are getting A cross B, it is equals to AB. That is, if I am moving in the anti-clockwise direction, it means I am taking the positive sign outward away from paper. And if I am getting B cross A, or simply I write A cross B equals to minus AB, it means I am actually moving from B to A vector. That is coming in the inward direction. Then you have to write it as B cross A equals to minus AB, or simply I can write it A cross B equals to minus AB if the direction is clockwise. It means I am moving in the clockwise direction even if I can move from A to B vector, but my theta is given in this direction. So you have to see to it whatever direction theta is given, clockwise or anti-clockwise, and then you will be writing the value. It can be positive, it can be negative if theta is 90. The same thing you can use for I cap unit vectors, I cap, j cap and k cap. You all know I cap, j cap and k cap are the unit vectors along x-axis, y-axis and z-axis respectively. So if I am talking about I cross j, I will be getting perpendicular to it, means I am in the xy plane, my result will be along the z direction. So I will be getting k cap. Similarly, if I am moving from taking the cross product of j and k, it means I am in the yz plane and my unit vector will be along the x direction, I cap. Similarly, k cross I, it will be coming out to be equals to j cap. But if I change the direction, it means in place of I cross j, I am going from j cross I am getting the result minus k cap. Similarly, k cross j is coming minus I cap. I cross k, if I take, it is coming minus j cap. Now sometimes you people get confused in about these unit vectors. So you can draw a circle and keep this in your mind for a longer time, that if I am making I, j, k kept on the circle, I move in the anti-clockwise direction. This is the anti-clockwise direction. It means I am moving from I to j, then to k and k to I. Then I will write the positive sign. This way I am moving outward away from you. Positive sign. So I cross j is positive k, j cross k is positive I, k cross I is also positive j. But if I am moving in the otherwise direction, same, but you change the direction now. Now you will be getting I cross k will be negative of j. So you can write it here. Similarly, if you are taking k cross j, that will be negative of I, and if you are taking j cross I, then it is equals to minus of k. So this way, simply for anti-clockwise, you will be getting the positive values. For clockwise, you will be getting the negative values. You can draw the circle and keep the signs in your mind whenever we have to take the cross product of the unit vectors. So this is just talking about the vector products in the rectangular components. If I am talking about the A vector you can write it as ax I cap plus ay j cap plus az k cap, and B vector you can always put the vector sign over it yourself. Bx I cap plus by j cap plus bz k cap. Now when you are taking A cross B, A vector cross B vector, then ax I cap with bx I cap you are doing, then I cap into I cap with itself, it will be 0. Now if you take I cap with j cap, it is k cap. Result is, so ax by k cap. Similarly, when you take I cap with k cap, it is coming minus j cap, already discussed. So ax bz will come minus j cap. Similarly, now if you take the second component of A vector, that is ay j cap with I, j with I is minus k, j with j is 0, j with k is I cap. Similarly, if you take az k cap with bx I cap, k cross I will be equals to j. Similarly, k cross j will be equals to minus of I, but k with k cross k will be equals to 0. So you can combine these things in this form that it is coming out to be I. I'm having two terms with me for I cap. One is this and one is this. So I can write I cap out and I will be getting AY BZ minus AZ BY. Similarly, you can take terms with J cap. J cap is one is this term J cap and another is this term. I'm writing it in terms of minus J. I'm getting it AX BZ minus AZ BX. Similarly, when you take the K components, K cap is out, then you can write it as AX BY minus AY BX. So see to it, whenever you write, this is a cap, you have to put on all the I's, J and K, and you have to always put the vector sign over the vectors. This you take care. I'm not putting on at all the places, but you should be knowing this. Now this is one thing, one method of taking the product. But if I write it in this determinant form, then the things will be easy for me to work. I will be getting the same result if I do by simple cross product method, which formulas I have learned till now, or I do by the determinant method. To do by the method, you have to just see this thing again. You can make a matrix like this, determinant, and you can write I cap, J cap, K cap at the top, the first row. Below this, you can write the components of a vector like AX, AY, AZ, I have written, and then you can write components of B vector, that is BX, BY, BZ. And you have to see to it, you have to remember plus, minus, plus. And you have to remember, whenever you have to take the product, you will be taking from the right hand side upwards. Right hand side upwards. And then you can get the result like this. If I want to take the multiple of I cap, I will be simply ignoring this column of I and row of I. Then I am left with only these four terms with me. And for that, I will be taking the product that I am getting BZ AY, or I can write AY BZ because these are the magnitudes, minus AZ BY. Similarly, when you want to take the multiple of J cap, you will be ignoring this row and column of J. This will go. This will also go. So you will be coming with BZ AX, or you can write AX BZ minus AZ BX. For this is moving upward minus the other term. You have to keep this thing in your mind. Similarly, for the K component, plus K cap, if you are writing, sign we are taking from the top, plus, minus, plus. So you are getting, you will be ignoring this row and column of K cap. Then you will be getting AX BY minus BX AY, or you can write AY BX. Here it is BX. So then you will be getting the same results whatever we have got earlier. So this is very important to write it in the component form, and we can use this directly in our numericals. No need to mention the things, you can directly, like this is one question I have taken for you. You have to determine the sign of the angle between the vectors 3i cap plus j cap plus 2k cap and 2i cap minus 2j cap plus 4k cap. The question says find the sign of the angle. If they simply say angle, then I can go with dot product. Now they are compelling you to find the cross product. It means because they want sign of the angle. So you have to take A cross B. We are doing by determinant method because it's easy for me. Plus, minus, plus I will be using with I cap, J cap and K cap respectively. I will be ignoring this. I am left with 4 into 1 minus of this 2 into 2 minus 4. So I am getting 4 minus of minus 4. So no need to write the formula, you can simply write these values. Similarly for j cap, minus j cap, if you want the value, this is 4 into 3, 12, minus 2 into 2, 4. Similarly for k cap, you will be ignoring this column and row, then you are getting minus 6 minus 2. And you can work out, this is coming out to be 8 I cap minus 8 j cap minus 8 k cap. Now if you want to write its magnitude, you can write by that formula which we have done in the previous class. I will be taking this magnitude square plus this magnitude square plus this magnitude square. I will be getting the magnitude of A cross. If I want to find the magnitude of A vector, I will be simply squaring and adding the components of magnitudes of A vector. So I will be taking 3, this is 3 square plus 1 square plus 2 square. So I am getting it square root of 14. Similarly for magnitude of B vector, I will be doing 2 square plus 2 square plus 4 square. So this again I am getting the square root of 24. And I know this formula for sine theta. Sine theta is the A cross B divided by A vector magnitude and B vector magnitude. That is giving me the sine theta value. So I can write the magnitude of A cross B divided by the magnitudes of A and B vector. I will be getting the sine theta value, which I am getting 2 divided by root 7. Now another question I have added to it, that is you have to find a unit vector perpendicular to the two given vectors. It means A and B. A and B vectors are given. You have to find a unit vector which is perpendicular to the two given vectors. Then n cap is equals to the A cross B vector, because vector is having the direction, divided by its magnitude. Given vector divided by its magnitude gives me the unit vector, as I have already discussed with you in the definition. Unit vector is a equals to the vector itself divided by its magnitude. So vector itself is A cross B, magnitude is modulus of A cross B. So you will be putting the values, you are getting 8 I cap minus 8 j cap minus 8 k cap divided by 8 root 3. So this I am getting the result 1 by root 3 into I cap minus j cap minus k cap. So these type of questions can be asked. Of course, another question with you, if they are asking you to find the area of the triangle formed by the tips of the vectors. Now they are giving the tips of the vectors, means A, B, C are the tips of the vectors, and you can make a parallelogram by this. You can use the physical significance of the cross product of the vectors. Now it means I want BA vector and BC vector. These are two vectors with me whose cross product I have to take. So this concept of displacement vector is to be used. It means this coordinate is given, this coordinate is given, this coordinate is given. So I will be finding BA by simply subtracting A minus B. This is simple subtraction. I am getting the result minus 3 I cap plus 2 j cap plus minus 4 k cap. Similarly, for finding BC, you have to do C minus B, and you will be getting the value. And this finding cross product, I think, is very clear to you now. You can find, and you can find its magnitude by taking the square and adding them, all the terms. 10 square plus 7 square plus minus of 4 square. I am getting square root of 165 as the magnitude of BA cross BC. And half of this I have to find. So this is will give me the area of the triangle. This is again a different question. I am trying to collect different questions so that every category I am trying to give it to you. Like I am giving you the diagonals of the parallelogram. They are given by the vectors 3 I cap plus j cap plus 2 k cap. These are the diagonals now. These are not the points. Earlier question, they were the points. Now they are giving you the diagonals. So I have drawn this parallelogram for you. And your concept of parallelogram law of vector is known to you, that if A vector is this, B vector is this, then this vector, which is having the diagonal from the same point where these two vectors are joining, tips of these two are joining, then this is giving me the resultant vector, which is equals to r vector, which is equals to a plus b vector by the parallelogram. But if you take this other diagonal, then it, of course, it is on the same lines. You can write b vector plus this vector, it is equals to a vector. So this is giving me a minus b vector. So these two diagonal, first diagonal is giving me always a plus b vector, and the second diagonal is giving me a minus b vector, because by default I go with this diagonal which I have studied in parallelogram law vector. And then the second vector, second diagonal which they are giving, that will be equals to a minus b vector. So this is these two diagonals are given as per question. And if now I know what? I know simply to find the cross product of two vectors. If I want to find the cross product of a vector and b vector, these are the two sides of the parallelogram, it will give me the area of the parallelogram. But I don't know a and b vector, rather I know a plus b vector and a minus b vectors. So what I am doing is, I am just finding this thing here, if you take the value of a minus b vector and a plus b vector, cross product of these two vectors, you are getting, then what you get? Then you get equals to half of this I have written, because that is going to further help you to prove that if I write this way, then it is not going to make any change in my equation. It means this is again a formula which you can keep it in your mind for the further use, that a cross b can be written as half of the cross product of the diagonals. And diagonals are a minus b and a plus b. I am taking their cross product. If I take their cross product, then a cross a plus a cross b minus b cross a minus b cross b. These steps I have simply written to prove it, so that you don't get any confusion in your mind. I have proved it that I can write a cross b, it is equals to half of a minus b cross product with a plus b. It means if in the question diagonals are given, you no need to draw this. You simply use this formula a cross b. Thank you everyone.